Perfect. Hi, everyone. I'm Rohan, a Principal Solutions Architect. And today I'm very excited to be talking about how Versa SASE can help secure hybrid multi-cloud. Let's take a look at a journey of any organization as they go ahead and start adopting hybrid multi-cloud. And here I want to focus on three important use cases and the plethora of challenges which inevitably come along with them. So the first one, right, it's a very fundamental use case. How do you secure my on-premises cloud and get my applications from on-premises into the cloud, right? Now here, the main challenge is actually around making sure we have cloud native controls, but more importantly, having cloud agnostic security between my on-premises and multiple different cloud environments. And the first use case really applies to any enterprise looking to basically take their existing application portfolio on-premises, modernize it and move it into the cloud. The second one, right? Now that you have your data, assets, and application in the cloud, so now what? So the next thing is, how do you prevent a compromise of one particular cloud workload from actually going ahead and spreading to other workloads or containers at both a micro as well as a macro level? And the last one is DR as a service, right? Which basically means as an organization, you should have the flexibility to pick and choose any hyperscaler that you want based on what service is best offered by that hyperscaler. And in doing so, make sure that you can seamlessly switch context between these different clouds while making sure you have cross-cloud security compliance. So why Versa for hybrid multi-cloud in the first place? So where Versa is fundamentally different from the rest of the pack is that we have taken things like advanced security from a layer 2 to layer 7 perspective, SD-WAN and basically carrier class routing, and unified that into one single OS called VOS. And the beauty of the solution is that that single operating system could be consumed on any kind of on-premises cloud, any kind of commercial cloud, any kind of gov cloud, or even beyond that. And that robustness is exactly what has made Versa a suitable fit for securing hybrid multi-cloud. What I have here is a typical canvas that you're expected to see in any kind of production environment, right? Which is a hub and spoke kind of design from an infra point of view. Now, let's say that you've moved your data assets and applications and you have taken them from on-premises and you've distributed them across all these clouds. Because that's not where the challenge is, right? The challenge is not around things like compute and storage. The challenge actually is around getting consolidated, unified security with optimal networking. Now, why do I say that? Now, if you just take your on-premises environment and you take a couple of different clouds, right? Azure, AWS, GCP, and Oracle. Now you're looking at maybe 25, 30 different security stacks in order to get you, end-to-end zero trust network access, right? So if you're looking at, AWS or Azure for that matter, you would look at things like Azure Sentinel. You would look at things like ALG, maybe WAF. If you're looking at AWS, you'll try to use CloudWatch and CloudTrail metrics, marry that with something like Lambda. If you're using GCP, you'll use the Network Security Center suite. Now, all of these are different point dedicated security stacks. They all have different upper limits, and it's really difficult to stitch them together. So that is where that previous stack, which I talked about from Versa, that software-defined stack, basically comes into play. So what we can do from our orchestrator is that, with full zero-touch provisioning, go ahead and instantiate our different VOS nodes across both on-premises and these different commercial or gov clouds. And what will happen is, once it does a call home back to the orchestration service, it'll download all of the security templates that we need from a layer 2 to layer 7 perspective, bootstrap the device, and give you full cloud workload protection. And I'm going to talk about that in detail. Okay. Now, let's say that, as an organization grows, if you want to move between multiple different environments, right, or you want to move to multiple different clouds, you don't need to reinvent the wheel for security again and again and again. Because the entire construct of security in Versa is templatized, meaning you can program it once and then go ahead and disseminate it across hundreds or thousands of these instances, irrespective of what platform or what environment they're on. Now, let's say, for this kind of architecture to really be robust, right? If I talk about a user who's at a branch, right? How do they get, contextual access into any of these cloud workloads? So what would happen is they would basically leverage the Versa SASE on-prem, right? Which is another differentiator from our entire solution, discover this entire topology and dial into this multi-cloud fabric. If you have a remote user or, someone who's working from home or who wants to get, again, contextual risk-based access into either any of these private workloads or maybe internet access, like we saw in the previous section, they would simply need to dial into that globally distributed SASE fabric and then dial into this and then get seamless access into the cloud. So, what I'm going to focus on now, if there are no questions, is look at, how we can actually go ahead and build these cloud gateways and go ahead and download those ZTNA templates from a layer 2 to layer 7 perspective. Perfect. So let me log into the Versa Orchestrator. And what I have here is a very simple template, right? I just have a couple of interfaces. I can choose if I want to mesh with any kind of cloud native service like virtual WAN or transit gateway. And the rest of it are just optimizations from a routing, application aware steering perspective, which I can also choose to do using our workflow. Now, what I'm going to show you is just how easy it is to bring up a cloud gateway using Versa, right? So all I do is I go and say, add a new device. And let's say this is going to be Acme Cloud Gateway, Security Field Day 001, right? I choose the organization. I go ahead and select it as public cloud. And then when I click on continue, it's actually going to prompt me with which environment I want to deploy my cloud firewall on, right? So let's say that we want to go on Azure. And here, now you're actually prompted with a dropdown which tells you, okay, I want to go ahead and orchestrate it in West US. And you can actually see the spinner wheel moving over here, right? So I'll tell you what's happening in the background. What's happening in the background is that, our orchestration platform is programmatically talking to the resource managers of Azure and AWS and discovering all of this infra which exists in the cloud, right? So that means like VPCs and VNets and subnets and security groups and all of that. And it's actually reading that information to present on our dashboard. So if I come back now, you can see that, it's showing me all the different resource groups. In this particular setup, I just have, 2 resource groups which are here. So I'm going to select the resource group. I could also go ahead and select an availability set to make sure I have HA. I can select the instance type that I want to use, the VPC network, which it discovered, right? And the image. And like we saw, I had 3 different subnets. So I could go ahead and select management, let's say WAN and LAN. And these are all dynamically discovered from the cloud. And let's say I want to go ahead and put these security groups. And when I click on continue, it's going to ask me, do I want to add on anything extra? So this is where that programmable security template basically comes into play, right? So I've created a layer 2 to layer 7 template. I'm going to show you what that looks like. And I just go ahead and call this, right? And then I say, okay. And when I click on next, it's actually just going to give me a prompt saying that, we're going to go ahead and deploy on Azure or AWS or GCP. And that's when the billing cycle starts, right? So I go ahead and click on deploy. And this process typically takes around, 6 to 7 minutes, but now you can do it at scale, right? You can build up how many of a firewalls you want at scale. So that is...
Rohan, maybe I missed this when you started, but I saw when you clicked on like devices, it showed, a couple of Ethernet ports, management, ETH0, ETH1. And are you actually deploying a configuration or a template to a physical device now? Or these are just logical interfaces?
These are logical interfaces. Now, because it's a hybrid cloud platform, right? We really didn't distinguish between, whether you're doing it on-prem or in the cloud. So we always give you these ports. And if you see over here, right, you can actually go ahead and say BNI00, which is the logical port. You could go ahead and select a different network for it and then choose how you want to put it on DHCP or static, etc. But right now, I've orchestrated all of this into the cloud, as we saw, as part of the cloud discovery and other things that I just did.
Yeah. Okay. All right. Got it. Thanks.
Questions from my side. Sure. Correct me if I'm wrong, but these Versa gateways are just regular virtual machines inside the cloud, right?
This is so we have multiple different offerings. So what I showed you now is basically an IaaS service of Versa in the cloud. What we also do is basically we deploy it as a managed application. Now, certain cloud providers like Azure and AWS give you the option of actually deploying the Versa VOS as a managed application. And so does Equinix for that matter. So you could do either option, which is basically go ahead from the marketplace of those different hyperscalers and deploy it as a managed application, or go ahead and deploy it from our director as a IaaS offering. So the choice is up to what you want to do.
Yeah, and from the VPC standpoint, what can you control there? Do we need to manually configure the routing table to point routes to the Versa gateway, or
that's a very good question. That's a very good question. So what we do today is basically we offer Terraform templates, which can go ahead and discover all the route tables and change the routing to now point to Versa. And the reason why we do that is because changing route tables could be a little bit of a service disruption to services, and we want to give that control to the cloud admin to make that decision. But yeah, and that's the model that we use basically today in order to fire off.
Terraform template is built-in inside the console, or it's a separate thing?
We can fire it from the console. We can basically fire that from the console, because at the back end, basically the Versa director can go ahead and talk programmatically to all of these, right? So we can just fire this from the console itself.
Okay, thank you.
Right. So that was, and that's basically how you deploy basically a cloud gateway, right? Just as simple as that. Now let's actually see, how robust this particular cloud gateway can be, right? And in order to do this, what I've done is I've just logged into one such gateway. And even before that, right, let me show you what kind of topology that I have. So this is the topology that I've basically built out. So you can see there are some gateways on Azure. This happens to be in the California data center. There are some 2 gateways on AWS, which are in the Ashburn, DC, right? And then there are a couple of gateways on Equinix, a couple of them on-prem. So there are about 8 gateways, give or take, in this entire topology. And what I'm going to do first is basically show you if I go ahead and that layer 2 to layer 7 security policy that we saw previously, I just go ahead and say, allow everything. Okay, let's just go ahead and say, I don't go ahead and select anything. I'm just going to go ahead and say, I just want to go ahead and allow everything. Okay. Now, what I'm going to show you is that, between workloads which are there on Azure and workloads which are there on AWS. So one thing which I forgot to mention is, as a result of just bringing up these cloud gateways and having that seamless connectivity, that smart pipe connectivity dynamically established, you now have basically multi-cloud connectivity between Azure and AWS as well. But we want to really talk about security and focus on security as part of this of this entire presentation, right? So what I'm going to do now is I'm going to basically inject live payloads, live attacks, basically from Azure, and try to propagate them into AWS. And let's see what happens on the back end if I don't have Versa, right? So I basically just said allow all for all the transactions going through, and we'll see what happens. So let's have some fun. Let's go and fire up some, full suite attacks. And I am going to basically save and run this. And this is basically going to go ahead and use 10 different hosts on Azure, 10 different hosts on AWS, and basically fire in all these strikes between them. So I'm going to show you exactly what I am firing as a result of the payloads over here. I just want to keep your eye on this particular tab at the bottom here, where you see the total allowed strikes. Out of 262, we already see about 201 of them are going through. So what exactly is part of this strike over here, right? So I'm going to go here and I'll show you exactly what I've gone ahead and configured. So you can see that it's actually looking at, all kinds of buffer overflow attacks. You're looking at deserialization attacks. You're looking at code execution. I can even see if we have some popular ones over here. So maybe, yeah, there you go. So there is even the SolarWinds Orion API bypass attack. So that's the entire strike, which was basically moved between the workloads on Azure to the workloads on AWS through that particular cloud firewall. But remember, I just said allow all. So that's why all the strikes went through. Let's actually come and take a look at what the report finally stated, right? So if I come here and if I take a look at the report, it's about 82% done, but you can see that, out of 262, 202 attacks actually went through. So definitely not a very good picture between those vulnerabilities being exploited between Azure and AWS. So I'm going to stop the test now, and I'm going to show you live, just the kind of control we can get now between these transactions which are happening. So all I'm going to do is I'm going to come back to my corporate policy, and I really want to focus on what's available out of the box, right? We already saw in previous sections just how granular we can get in terms of the details of going ahead and configuring security. But let's say that, I just want to use my out-of-the-box profiles, which are available through the Versa suite, right? So I'm going to go ahead and enable these different profiles. And I will also talk through very briefly what we do in terms of just out-of-the-box based solutions, right? So from basically from a vulnerability standpoint, we support over 30,000 predefined signatures. From an IP filtering point, there's over 12 plus IP reputation signatures which are matched. From a URL filtering point, of course, it's billions and billions of URLs, and we do a cloud lookup as well. So that's the entire stack, which I'm going to basically go ahead and turn on this cloud firewall, right? And now let's go ahead and see what would happen if we actually go ahead and repeat that entire strike. Okay, so if I come back to my dashboard where I'm going to fire these different strikes, I come back here And let's go ahead now and fire that exact same strike. Right. So we have it here. I'm going to save and run this particular strike. Okay. Right. Now let's take a look at what's going to happen. So, let the strike start. It usually takes about, 1 or 2 seconds for it. And you can start seeing that, it's about, it's starting to fire off all those different payloads. And remember, these are actually live payloads, which I'm going to detonate between those workloads, between Azure and AWS, right? And it is showing that, we have started off at about 1%. There are about 3 strikes which are blocked, and let this keep going on, and we'll come back and take a look at the report in a bit and see, exactly how much got blocked and to what extent. So in the meantime, right, what I want to also talk about while this is happening in the background is about our security package, right? So we looked at what's available out of the box, but how do we really keep it up to date? So that's where the Versa SPAC or the security package comes into play. And what this does is that, it's a database of, the different geo-IP locations, the application identifications, the URLs, malware lookups, the CASB DLP profiles. And this is actually actioned by multiple different sources, right? So we have our own internal IPS signature team, our CSIRT team, which basically actions different items in these databases. We also get real-time threat intel as well as monthly updates from our trusted partners. Now, what happens is all of this gets fed into this cloud SPAC server, and then this cloud SPAC basically can go ahead and disseminate all of these different security package updates in both periodically as well as in real time to these Versa appliances. So I think there was a question in one of the previous sections as to, how often can we do it, right? So we offer 2 modes, right? So one is going to be a daily mode and one is going to be a real-time, right? So basically daily update, as the name suggests, it's done every day. And basically the real-time update is done once every 30 minutes, which is a update on top of the daily update, right? So that's how we can keep everything basically up to date, irrespective of what environment that it is going to be deployed on. Let's log back in, right? And let's see what happened over here. All right. So there you have it, right? 100% of all those strikes which I showed you, and some of them, very, very, very recent strikes being blocked just by out-of-the-box security controls that we have through the Versa stack. And just to show you, how this all looks like from the analytics point of view, right? So if I come here, all I have to do is to go to my security. I want to go and look at my threats. I want to look at vulnerabilities. And here you can see all the different kinds of attacks which were fired. There's different signatures, the CVSS scores, which map to those different attacks. And if I want to go ahead and deep dive into what exactly that was, I could take a look at the threat type, what the signature message was, what action it took, the signature ID, whether it was from client to server, server to client, or both, what kind of application it was trying to access. And you can see over here, the other metadata that you would need for any kind of forensic analysis of this particular live vulnerability exploit, right? So with that, I'll just pause here if there are any questions, or if not, we could wrap up this segment.
Yeah, Rohan, I've got a question about just understanding what this is protecting against. So the automatic updates and stuff does sound quite cool. So this is essentially a firewall that's sitting in between 2 VPC, so one in Azure, one in AWS in this example.
Correct.
And so that's where the enforcement location is. So the traffic that you're detecting here is coming from within my own VPC. It's not coming from external thing. Okay, so this is protecting me. This is essentially one of my sites has been compromised, right, and this is preventing lateral movement between those cloud environments.
Absolutely. But you know what? Okay. That's the beauty of the solution, right? If I wanted to have this on-prem, right, there's absolutely no difference, right? So whether I'm going in this direction and getting into my cloud workloads, right, using our contextual access policy, we basically scrub it, or whether it's going in the east-west direction, it really doesn't matter, right? So you can, because at the end of the day, right, it's the exact same operating system which goes either in the cloud, either on-prem. So now you have the flexibility of saying, I have a golden security template like what I just showed you, and I want to go ahead and push that in any direction, east-west, north-south, or any other combination between, across all these different platforms. And I want to ensure that, I have risk-based access into my environment.
Okay, so could I also use this to protect any environment from ingress traffic from the public internet?
Absolutely,
Okay.
right? So for ingress traffic into the internet, what you typically do is that you would use maybe a public load balancer service from, let's say, Azure or AWS, or an application layer gateway of some kind, right? And then the traffic would come ingress. It would basically distribute across these different Versa appliances. You would scrub the entire traffic always based on the user, device, group, application, threat, and content, and only then give it access into the environments on the backend.
Cool. Okay. Thank you.
Right, and an important thing here, right, which is also differentiator, is as a de facto standard, just by building this entire gateway over here, right, you got connectivity not only between clouds, but from your on-prem to clouds as well. And this connectivity, I'm actually going to show that in the next section, tracks, real-time application metrics as well. So you're really marrying, security with application-driven optimization to blend in a combination of making sure that compliance is met, but user to application performance is also guaranteed.
Can you also use this between the two different VPCs that I see? I see prod and dev, and they Azure prod and dev.
Absolutely.
Can Versa sit between those?
Absolutely. And in fact, that's a very good question. In the next section, what I'm going to show is what we do from a macro as well as a micro level, right? So one is between two VPCs. But what if it's but if it's two workloads in the same subnet in the same VPC? Then what happens, right? Then the story changes completely. If you look at a typical solution that you would need to actually prevent you from a micro segmentation kind of lateral movement, right? And that will basically come in the next section, and I'll talk through that. But the short answer is yes to both scenarios.
Rohan, I wanted to jump in with a question, which is the whole premise of SASE is really moving the entire security stacks that you would typically have on-prem in your perimeters at your sites, and moving that to the cloud and sort of forcing everyone to go there to access resources,
right.
Which is a great model. So when we do that, right, typically we want to give up our stacks, right? We want to stop having our local firewall and IPS and web proxy and all of the things that we stack together at our perimeter edge. And instead, we just want to route through a tunnel up to the cloud and let that handle it, right? That's what your product is. But that's what the SASE model is. Okay, so my question is, when we do that, you just gave a threat simulation model as you go from one cloud to another. What are you using for signature-based detection, right? Are you using, Suricata or Snort under the hood? Are there signatures that we can write? If there are things that we need to write, how do we implement them? And then I think I also saw in your dashboard when you were clicking through, and I hope you get to it at some point, but typically we need to have packet capture, some form of packet capture locally. So I did see that in your dashboard. I hope you can demonstrate how that works, at a micro segmentation and a macro segmentation level, what we're able to see with that.
Absolutely, right. So let me just show you, for example, if you come to any kind of vulnerability, right? So first of all, the rules are in Snort format. That's absolutely right. You could also choose to create your own rules in Snort format and have them updated here. So you could use both the user-defined rules as well as the as well as different predefined rules. And when you go ahead and say enforce, right, this is where you can select packet capture, right? So you can say you can have a pre-window and a post-window, right? So when you say that I want to go ahead and before an attack happens, when it starts to actually fire off the signatures, go ahead and do a packet capture on both pre and post. And that is something that you can also use out of the box using our solution stack, right? So both options are available, as well as all the different granular controls that you want over here. And that's what we also looked at in the previous section, right? All these different granularities of how deep you can go into the stack.
No, that's really interesting. I haven't seen that from other vendors, not implemented in the same way. But I'm just curious, what are the specifics on the pre-window and post-window? Is it 1 second before and 1 second after? Is it one packet before and one packet after? Is it one session before, one session after? What is the one in the one there? What does that actually signify?
Right. So the pre-window would actually be n number of packets before this and n number of packets after this. So the very first pre-packet where the signature was initially identified, you would start capturing. And how many packets do you want after that, right? How many packets do you want after that window of that attack which that signature had? That's what you can use in pre and post. So
okay, I got it. So it's not capturing the whole session. It's doing what would typically from Snort or Suricata, which would be just capturing the single packet that the signature triggered against.
Yeah.
Instead,
So
this is offering you a leading packet and a trailing packet on either side of that, right?
That is correct. Yeah. So for forensic purposes, you want to capture as many packets as are needed for that particular attack, right? So the pre-window, what that means is that we are always buffering those pre-window number of packets in memory at any given time, regardless of whether we find an attack or not. So that's kind of like an overhead that we incur for every session because of the pre-window. Right? But then once we match the signature, then the post window actually kicks in, and we would actually then start capturing how many packets you want. That's not much of an overhead because we already like identified that, hey, we found this attack, and then we can keep capturing packet for however long we want. That's a cost on that particular session on which the attack was found, but not cost on the other sessions. However, the pre-window will incur cost in every session, whether a match was found or not. So I would like to clarify a little bit more because there were a lot of questions earlier, and would like to cover all the different questions. So internally, we built our own IPS engine. So we are not using Suricata or Snort, or it's only our own homegrown engine. So what we do is, our IP lies in the tight integration of all the network and security functions that we have built, and we made it multi-tenant, fully be able to run on any platform, physical or virtual. We actually do zero-touch provisioning. So where when we deploy on the cloud, it automatically spins up. We do all the virtual plumbing. We attack all the traffic. We inspect. So it's as least intrusive as possible. And it automatically starts enabling those network and security functions as you have configured them. So when we actually write our own rules and we deliver them, we provide the customers the ability to write their own signatures, or ingest those signatures from third-party sources that they can get. So on a per traffic basis, we can apply just the customer rules or the Versa rules, or a combination of both. And the packet captures are also pretty flexible in the sense that we actually do not store any of the packet captures on the appliances. We actually ship them to the analytics, so that when you go to the analytics, you see that there's an attack was found. You'll find the packet capture right next to it, and you can export it and do threat analysis, research analysis, and so on.
Absolutely, right? Absolutely. And just to clarify, in case I was also not clear, one of the formats in which you can write your user-defined signatures happens to be in the Snort format. So, yeah.
Can I ask a question?
That's great. I would just say I would like to give a piece of feedback, which is I would encourage you guys to also offer a checkbox for capturing the entire session, because sometimes just one packet isn't enough to give context.
Yeah, absolutely. So that is actually configurable. So, right now, the user interface doesn't offer that, but if you actually typically set the pre-window and post-windows to a very large number, then you will capture the entire session. So, but then, we actually have packet captures in multiple places. So this is the IPS part of the screen where you see in the packet capture option. We also have a packet capture on the security policy where for a given set of traffic that matches a certain criteria, you can actually enable full packet capture for all those applications. So that is also available. We also offer another feature called flow mirroring, right, where you can define a certain set of traffic for which we enable full packet capture. Then we can ship it off to another packet receptor via IPsec tunnel or
Yeah, that's great. That's a great little added bonus if we have other utilities ready to receive that. That's awesome.
Yeah. And here, right, if you take a look at this screen over here, so this is really matching anything that you want in one single shot, and then you can go ahead and enforce a packet capture as well, right? So it's not just saying only if it is, so you could be very granular, right? You could say only if it is IP filtering, go ahead and do a packet capture. Or only if it's a combination of one or more of these, go ahead and do a packet capture, right? Only if it's coming from a certain source zone, go ahead and do a packet capture. So you have, kind of the complete granularity of what you would want to use in the stack based on what is needed.
Thank you, guys. I appreciate it.
Thank you.
Perfect.
I had a quick question just to extend out. You mentioned the ability to get the packets off of this platform, if you will. So as a security product, you may have other security tools or methods of investigation you want to use to pull it back into SIM, SOAR, pick your S starting acronym in the security field, right? Can you maybe just spend a few seconds and talk through what the ways are to get data off of the platform? And if you have that coming later, don't let me get too far ahead.
Sure. We could absolutely talk about it, right? In fact, let me pull this up, right? So here, I'll show you very simply, what we do, right? So for example, once this is basically our head end, right? And what we showed you is that once the logs are generated on, let's say, a cloud branch, that goes into something called our analytics, right? Which I just showed you now. And from the analytics, we could go ahead and export it to any other third-party SIM source solution of your choice, right? So we expose 100% of our APIs northbound. We also, you could write different runbooks in order to do, kind of reverse feedback if you want to do it as well. So, this could be any other SIM or source solution that you want, right? So that's...
so I would like to add that even from the appliances also, you can go direct to the third-party log collector for bypassing our analytics. However, we recommend going through the analytics because our analytics actually has adapters built in so that, we actually receive the logs and we translate automatically to the third-party SIM format, and then even standardized formats like common event format, and we can ship the logs to any other sources. We also have support for NetFlow. So we have multiple different mechanisms. It's very flexible options, to choose whether you want to send the logs and the packet captures and the NetFlow, right from the appliance itself directly to to the collector, or you can actually ship them to the analytics, and then from the analytics we can re-export them. And all of that is going on real-time streaming. There's no batching or no latency or delay. So it's just as the traffic is being processed, we actually stream the logs upstream. So
absolutely. Right. I hope that answered all of the questions. And we also...
One quick question about the NetFlow. Is that sampled or is that information on every single packet flowing through?
You can use both options.
Or configurable. Okay.
It is completely configurable. You can use both options, whether you want to do a interval-based NetFlow or whether you want to do a full or a per packet-based NetFlow. So it's configurable.
Just to extend, this Remington, is it actual NetFlow or are you using one of the other flow, like IPFix or SFlow or all the things?
It's actually NetFlow. So we have multiple ways in which we can export data. So one of them happens to be NetFlow. One of them, you can also do IPFix, which is syslog version 10. You could do syslog version 9. You could use basically syslog KVP format as well. So you have a bunch of options in which you can basically export these different logs.